So hi everybody, good morning. I'm John Miller, co-founder of Aeromana. We're a startup based out of South Pasadena. And we're going to talk today about a tether system that we've been developing. We brought with us today a box that was a simple integration with the DJI Phantom, which we'll do a brief demonstration of. But just to kind of get started, I'm here with my colleague today, Rashad Moref, and Joseph Keeler, who's here in the audience. And we're Caltech scientists and engineers. We started Aeromana about 3 years ago doing Department of Defense work related to high energy consumption platforms with drones. And so that led to our development of a tether system, which we have now begun to develop and commercialize through prototype versions. Advancing here, fundamentally the types of use cases that we envision with site management of tether systems, security and surveillance, also for first responders, obviously, and that's why we're here today discussing first response applications, as well as event broadcast, and also telecommunications. So that's line of sight relay in which you can put up the drone and allow it to communicate with other devices or LTE backhaul networks. Obviously, all of our attraction to drones for everybody here is that they are easier and lower cost than alternative solutions that can be put up in a structure fire or search and rescue scenario. Obviously, the number of certified commercial operators in the United States is growing very rapidly, now at last count by about 41,000. And we also, there's estimates of a 5-year, $20 billion commercial drone opportunity that's evolving. And this year, worldwide, there's poised to be about 2 million consumer drone sales, of which commercial drones represent a small but growing number. And currently, the problem with drones for commercial use is that they have very foundational operational drawbacks related to short flight times, which we all know all too well, of generally less than 20 minutes. There's also concerns of flyaways, loss of operational control due to radio interference. There's the risk of jamming of wireless data. And then there's a limitation on bandwidth and downlink, which generally is constrained in most instances to 720p, but can be 1080p at most. And these have kind of been barriers to entry for utilizing commercial drones more widely. The advantage of using a tether is that if you constrain your operations to a fixed scene, or you're looking at like a local area in which you want to provide coverage and service, then you can solve most of these problems pretty robustly. So you can utilize the tether both for power to keep the drone in the air, but also for data in order to transmit data securely. And that's both data up, which is command, and data down, which is relay of the video feed. This particular system that we brought today is about 180 feet that it can go up. That resolution gives you about 1 pixel per inch on the ground. Our reel system inside the box is an automated tension reel that basically controls. We don't know if we want to. Yeah, we can zoom in there a little bit, but it takes the place of the battery bay, and you can pull out the interface. And then that slots into the battery. And then now you can power it from the ground. And this box is an entirely self-contained unit. It weighs about 17 pounds. It's about 14 inches by 12 inches, by about 7 inches in height. And with this, you can plug it into either a vehicle or a ground mains or, a basic larger battery or a generator, depending on what your application case is. The key advantages with the tether system is that it's something like a rapidly deployable suitcase tower. So it changes the interface that people have from being a pilot of a drone that's flying a drone to being kind of a set it and forget it tower that you could deploy in a fixed kind of base scenario. There's a range of applications, obviously, from first responders, event broadcast, security and surveillance, climate monitoring, site management, infrastructure monitoring, lots of cases that you can get to. You can also utilize this as an aerial networking hub. So this is wireless connectivity between the drone and other LTE station backhaul, as well as connected devices on the ground, including tablets for command and control, and any other wireless kind of tablets and entities there. This also allows for kind of unique aerial data sets based upon a long duration and structured interface. And this allows you to build really interesting software based in computer vision and machine learning for tracking of objects on a scene and providing value add to entities on the ground. And we've done this so far building out software for emergency response, where you have a very simple tablet interface that streamlines the flight control, and that allows you just an operator to just plug in and then immediately deploy to altitude based on single button press and motion around of pan, tilt, zoom, and then using these geotagging overlays in order to get firefighter accountability on a scene. So for example, you can see where folks are in proximity to a fire, you can keep track of them, and then you're also able, obviously, to use thermal infrared to kind of allocate resources and assets on the scene as you need. We have a brief video that we prepared here that we can launch, Rashad, if we've got it here. So, this is a structure fire scene, a training fire, thermal imaging overlay, from the drone. You can obviously see how you can allocate resources in a field. You can also do personnel tracking, even in the infrared domain, that allows you to get reliable, granular information down to an incident commander. And then we're also going to show you guys some of the other features that we've developed in certain other software configurations, but the same principles apply for public safety. So yeah, this is sort of using public safety as like event augmentation in like a scene where you would have a need for expanded CCTV coverage. Moved a little fast here, but this is a fun one that we've been doing, or we've been doing coaching tools for sports teams, right? So using the tethered drone to overlay and track, and you can see routes that people run and things like that. You can also do additional overlays related to scene understanding for augmented reality. And all of this is enabled by having that stable platform. In this instance, you can take a complex scene with lots of people, lots of movement, a single video image, and then you can break out simulated virtual images and sub-video that allows you to better understand the scene and track. We've been evolving this out for public safety now, and so this is a really exciting application and technology that we've been working with, and that makes it work really well. So do you want to jump back to the PowerPoint briefly? Yeah. Oh no, sorry, we're technical difficulties, folks. Apologies. But we are currently in development, and we're seeking development partners. So if you're interested in getting in touch and working with us to integrate kind of tethered systems into your public safety operation, feel free to email me at john@aeromana.com. And yeah, that concludes our presentation, guys. We can take questions, please. Yes.
I noticed FDNY has been using something similar to this.
Correct.
Is this the same technology? Is it similar?
So it's a similar technology. That's FDNY has an integrated drone and a ground station. What we're doing is that we're using an integration with already available commercial off-the-shelf drones. So, the price point for FDNY is quite a bit higher. I think it's about $75K, and this system currently is around $3K. So to give you an idea of, the order of magnitude difference. Now, that is, this is with a Phantom integration, but we also have integrations from the same box where you buy a different module, and that module allows you to integrate with an Inspire class or higher up with the new Matrice 200 from DJI as well. And we're also busy developing integrations for other platforms too. So the idea is, instead of kind of folks being locked into a single drone, which you're going to replace in 2 years anyway, with this system, you're able to integrate with any off-the-shelf kind of commercial drone, and then you can punch it up there and then develop these overlays over it. Yeah.
So would you say you don't really have to know how to fly a drone to operate this system? You can put it in the air, leave
Correct.
it alone? Okay.
That's it.
Yeah.
Yep. Set it and forget it. That's the goal. And we want the design point to really be like a tower, not like a drone, in the sense of having to be flown or maintained with an operator on the ground. Yeah. Please. Yeah.
Sorry, I kind of walked in a little
No problem.
A little bit late. Did you talk a little bit about the material that your tether's made out of?
We didn't talk about the material at all. I'm happy to. So,
just further second part of the question.
yeah.
Like resistance to cuts or abrasions for the propeller.
Correct.
Can you just elaborate on those two things for me?
Right. So what we're doing is that there's a Kevlar sheath that the basic cabling lies within, that's resistant to abrasive tear. That abrasive tear is something that we're very concerned about and we're developing around. But for the time being, like this particular system here is actually a Belden cable that's UL listed and that we're utilizing for like maximal weight savings. But ultimately, when we have a commercial product available, we'll be using the Kevlar system that will be able to resist abrasion and that kind of thing. And yeah, sorry.
You done?
I'm sorry, we're going in a great direction.
Yeah, please.
Heat resistance.
Heat resistance.
Have you put any thought process of people maybe flying these around smoke or those sorts of things? Do you have any kind of ratings?
So right now, we do not have a rating that's evolved based on heat resistance. That's something that we're testing right now, actually. But as part of the UL resistance, heat is actually something we've designed around pretty adequately, so that there isn't a lot of concern about heat as much as there is about abrasion or any sort, exactly, those sorts of issues. So those are things that we're currently evolving in order to make it commercially viable. Yeah. Mm-hmm. Yep. Yeah, please.
Yeah, do you have the ability with your imagery analysis to go upstream a little with some imagery fusion with other platforms?
That's our design goal, actually. At this time, we don't have that integration capability, but we are trying to make this as interoperable as possible. What's that?
Like if you wanted to go into multispectral?
Oh, yeah, absolutely. Hyperspectral and multispectral. Ultimately, it's agnostic to the drone and the payload. So what we want to be able to do is really evolve out the software layers based on this structured long duration video that is totally novel in the drone space, because all video to this point with drones is basically 15 minutes long, right? But you get very different properties and very different assets that you can start to evolve out once you have that reliable platform. So we're working on interoperability. That's a key design point for the software. Yeah. Was there? Yeah, please.
Have you worked with FAA or FCC as far as their blessing on this?
Well, there's no special category for tethered drones, right? So tethered drones operate under the exact same restraints and constraints of drone flight in general. Our hope is that in the future, as the utility of it evolves out and the safety aspects manifest clearly, that there'll be those opportunities. But we haven't engaged with FAA to work with getting any sort of special requirements for it. The reality is that keeping the flight within 150 feet is generally within the design point of below any sort of interaction with other aerial firefighting, like in a wildland fire scenario, or anything else in that kind of sense. So, yeah.
So I guess what you're saying is sorry, because you don't have a way to sort of navigate FAA requirements.
No, there is no circumnavigation via this. I mean, we certainly think that there can be in the future, but that's part of the brave new world of all of this, you know, where there currently the regulatory environment still regards a tethered drone system as just like any other drone. Yeah.
All right,
Was
thanks.
there-
Well, you guys can feel free. This is the last interview, so
Yeah.
if you guys want to ask questions now, go for it. Otherwise, lunch, and then we'll start back up.
Okay.
But yeah. you guys-
Are you from the Bay Area?
I'm not. I'm from Pasadena, actually.
Pasadena,
Yeah.
Southern California company?
Yeah, that's correct. So we're from South Pasadena, and it's a Caltech team in Pasadena that we evolved out, and we really started developing the system late last year and developing these integrations, and we've been working with manufacturers and building out kind of beta testing partnerships right now to really push things and get things going. You know, we have projects in the works with obviously a number of public safety entities, but also the video that we had is from different football teams and sports teams for event broadcast, and we are working with some major carriers for telecoms relay as well. Yeah. So, yeah,
Does
please.
the software have capabilities? So you showed like motion tracking,
Yes.
object tracking, and
Yep.
you showed thermal imaging. Can the software like cross platforms do those things so you're not popping off different camera modules to do different?
Exactly. So the objective of the software is to be as agnostic to the platform as possible, right? So it'll be an independent layer that's running on top of whatever the video feed is that's coming in, that is basically taking that sustained video input. So we don't have a constraint based on, you know, if you want to pop off and do thermal. You know, if you take, for example, the Matrice 200 upcoming from DJI, that allows you to do both thermal and visual at the same time. Overlays related to that are things that are currently in development. Maybe Rashad, you can speak briefly about it. You're the principal architect, yeah, of some of the software.
So, for example, within a trace, because you can get simultaneous visible and thermal imagery, you can combine them and show them the thermal image of the house that is burning overlaid on the visible area around it, so that the chief commander sees exactly what he wants to see instead of like swapping between the two images. So on the building house, on the burning house, show the thermal, and then for the other personnel, show the visible.
Yeah,
If
please.
I understand correctly, the software that you have now, trying to be agnostic, is just downloading just the raw data that's coming out of whatever drone that's being plugged in, and then you manipulate that real time.
So we manipulate it in real time, and it runs on the tablet, right, in real time that the video feed is coming down from. We're currently doing this wirelessly, but we also have obviously the wired option through the Tether in order to do that and integrate it. But the key enabling feature of it all is simply that once you remove the need for battery power and you can put the drone up there in a robust way, you can start to draw this data down, aggregate it, and then build these feature sets atop it. Yeah.
And have you created systems where you can have networks of these drones?
Right, where drones can communicate with each other. We haven't been doing drone-to-drone communication at this time, but that's something that's well within our roadmap, and it's something that we're going to be developing for. At this time, what our big milestone was being able to do cell phone calls off of the tethered drone platform, utilizing it as like a telecoms tower, basically, so back to LTE relay. So that's a very exciting project that we have ongoing. That's pretty cool. So